This recording is a further discussion of adding and subtracting rational expressions. I'm calling it part 3. It's to replace a video that I had made previously in person, and so I'm using a starboard to do this problem. So I've got 3 problems that are relatively difficult for us to work with that we have to add and subtract, in this case subtract, that have different denominators. So first of all, I'm going to remind you that to add and subtract fractions, you must have a least common denominator. And the least common denominator between a 6 and a 4 is the number 12. That's because that's the smallest number that either the 6 or the 4 divide into. But each of those denominators have an x, so the least common denominator for this whole problem is a 12x. So what I have to do is build up these fractions so that the denominators become a 12x. So this one has to be multiplied by a 3. So I'm going to do that over here on the left side. I'm going to multiply the denominator by a 3, but if I multiply the denominator by a 3, I've also got to multiply the numerator by 3. Therefore, in doing this, I'm only multiplying by the number 1. 3 over 3 is the number 1. So if I call this numerator 9x minus 6, and the denominator is now 12x, it's an equivalent fraction to the original, but it's built up so that it has this common denominator. This 6x needs to be built up to become a 12, so it's got to be multiplied by a 2, top and bottom. And so this 2 has got to be distributed times this binomial. So 2 times the 3x will give me 6x, and 2 times 1 will give me 2. And now this denominator right here will also be a 12x. Now remember, we are subtracting in this case. So when we subtract, when we take this fraction and subtract this fraction, we add the opposite of the numerators. So I'm going to add the opposite, which would be a negative 6x, and a negative 2. And now I'm going to go ahead and combine my like terms in the numerator. So 9x and a negative 6x combines to be a positive 3x, and then a minus 6 and a negative 2 combines to be a minus 8, all over the common denominator of 12x. Since the numerator cannot be factored, I'm done with this problem. There's nothing that can be taken out of this that I could reduce with that denominator. Okay, let's try a harder one. Remember, you must get a common denominator. So this denominator is a trinomial, and because the two numbers whose product is 30, 6 and 5, and add to be 11, 6 and 5, the factored form of that denominator is x plus 6 and x plus 5. Over here, this trinomial can be factored. Again, it's a 1x squared, so we know the first term has to be an x in each of the binomials because their product has to be x squared. The two numbers that multiply to be 20 and add to be 9, multiply to be 20, 4 times 5, add to be 9, are the rest of those binomials. So the least common denominator for these two fractions is an x plus 4, and I'm going to put them kind of in order, an x plus 5, those are both in the second fraction, and there's also an x plus 6. So I need to build up each of these fractions' denominators to have the missing binomial that they don't have. So this one's got x plus 6 and x plus 5. So its numerator needs to be multiplied by x plus 4. Now be careful. The proper way to write that is to show the x plus 4 down below as well. You're multiplying top and bottom by x plus 4. But a lot of people, when they write it both top and bottom, then they go and cross it off. Well, you just put it there. So you don't want to do that. So you're building up this fraction. So you're going to distribute this now and call this x squared plus 4x, and it's over the common denominator of x plus 4, x plus 5, and x plus 6. Okay, let's go on to the second fraction. So it's got an x plus 4 and an x plus 5. It's missing an x plus 6. So again, I'm going to show it top and bottom. Just be careful that you don't go crossing those off. Instead, you've got to call this 5x plus 30. So 5x plus 30. And now it has the same denominator as the first fraction because they've got all three binomials. Now I want to subtract the 5x plus 30. So I need to add the opposite of these two. And so in the numerators, when I combine all these numerators, I've got the x squared, and then this positive 4x and a minus 5x makes for a minus 1x. And then I see this red sign right here? The 30 is a minus 30 over the x plus 4, x plus 5, and x plus 6. Now finally, if I can, I think I'm done, but if I can factor this numerator, in other words, could I could put an x in the front of each of these binomials. If I could find two numbers that multiplied to be a negative 30, I'm thinking 6 and 5. They got to multiply to be a negative 30 and add to be a negative 1. 6 and 5 add to be a negative 1, multiply to be a negative 30. That's one's got to be negative, one's got to be positive, because they have to multiply to be a negative 30 and add to be a negative 1. And then my denominator, I'll copy that down. And I can reduce that final answer by removing the x plus 5's top and bottom. And so what I have upstairs is just that x minus 6. And downstairs I have the x plus 4 and the x plus 6. Okay, good enough. Let's try one more, relatively hard because of the denominators. So in these two problems, their denominators have a coefficient in front of the y squared term, in this case a 3. I might have enough time to take you through the long form of factoring a trinomial when the coefficient in front is a 3. And the way we've done that, typically in the past, it causes us to get the right answer the first time, every time, is to use the AC method. So I'm looking for two numbers whose product is a negative 12, and then I want the two numbers that I find to add up to be a positive 1, because right here in front of that y is a positive 1. Well, I know that those numbers have to be 4 and a negative 3. They multiply to be a negative 12, and 4 plus a negative 3 adds to be 1. So what I get to do is to take that trinomial, 3y squared, and change the 1y to a 4y minus a 3y. A 4y minus a 3y is this 1y, and then a minus 4. And now I'm going to factor by grouping. If you remember way back, to group, you group the first two. When I have a minus sign in front of the third term, I'm going to real quick change that and get that negative sign inside there. Then I got to take my greatest common factor out of this group. So the common factor is a y. And then look at this negative 3y and negative 4. It doesn't have a common factor other than to take a 1 out, but I better take a negative 1 out so that this binomial right here can be a 3y plus 4, and these will match. And then finally, in the process of factoring by grouping, I pull that common factor, that common binomial of 3y plus 4 out of each of those, and then this y and that minus 1 goes in the other binomial. I could do the same thing for this trinomial up here, but I'm going to do this in my head, and I didn't do it in advance. Let's see, I think that's going to have to be a minus 2, and I think that's going to have to be a positive 4. Yep. So there's the factored form of this trinomial. So the least common denominator between these two, they both have a 3y plus 4. One of them has a y minus 1. And one of them has a y minus 2. So I've got to build up these two fractions to have, and I'm going to recopy this over here. So the 7 is over 3y plus 4 currently, and the y minus 1. So I just took this fraction and rewrote it over here. And then the 9y plus 2, the second fraction, is over the 3y plus 4 and the y minus 2. Let's see. This fraction is missing of these three binomials. This denominator is missing the y minus 2. So I'm going to have to take that 7 and multiply it by the y minus 2, and that will give me 7y minus 14. Sometimes in my classes what I'll do is I'll just put these three letters under that. That shows me that this denominator is not just these two now. It now has built into it that y minus 2 as well. So the least common denominator is all of those. Over here, the 9y plus 2, that denominator is missing the y minus 1. So this whole thing right here is going to have to be y minus 1 because I'm multiplying top and bottom by y minus 1. Careful, when you take this binomial times this binomial, you have to FOIL it. You have to multiply those together, then those together, then those together, and those together. And what we get when we do that, I'm not going to show all the work, is 9y squared minus 7y minus 2 over that LCD. Oh, good. Finally, I'm ready to add these fractions. So I'm going to take their numerators and I'm going to combine my like terms. So you see, first of all, we've got the 9y squared. There are no like terms with it. But you see the 7y and the minus 7y, they add to be 0. And then finally, the minus 14 and the minus 2 add to be a minus 16 over the LCD. And then I need to be aware that that numerator can factor. That's called the difference of squares. So that can be factored into the product of two binomials. Because the square root of 9 is 3, I would put a 3y in the front of each of these. And because the square root of 16 is 4, I'd put a 4 in the back of each of these. One has to have a plus sign, one has to have a minus sign, so that when I FOILed this out, I would get that 9y squared minus 16. Finally, my common denominator, now I'm going to write it out, was 3y plus 4, a y minus 2, and a y minus 1. So I'm noticing that there's a common factor, a binomial factor of 3y plus 4 on the top and bottom. So I had to reduce this expression, my final answer, to become 3y minus 4 over y minus 2 times y minus 1. Rational expressions, adding and subtracting. Got to get common denominators, and you got to reduce them at the end if it's at all possible.